last few problems. So up here, look, you got this isosceles triangle, right? So that means that this angle and this angle have to be congruent. So just thinking about what we were doing before, since we don't know these angles, just call them a question mark. So we got this angle, T, plus my angle TAO, which we don't know, plus 50 has to be 180 degrees. Well, that's two question marks that I have there, or just call them X if you want. Plus 50 equal 180. Subtract 50 from both sides. Well, 180 minus 50 gives me 130. Divide by 2. And we end up with our missing angles being 65 degrees. These two guys. So measure of angle T, 65 degrees. TAO, 65 degrees. 65, 65. Okay? Now, to get over into this triangle, we're going to use a little fact between these two that we know from back when we learned in Unit 1 about linear pairs. Remember, these two angles form a straight line. They have to be supplementary. So these angles are supplementary because they're a linear pair, guys. All linear pairs are supplementary. So to figure out my angle OAC, all I got to do is take 65 plus my new question mark here. That has to equal 180 degrees because these are a linear pair. So you subtract 65 from both sides and you end up with our top guy being 115 degrees. So OAC, 115 degrees. And look right here. If you add these two numbers up, they add up to 180, which should happen because they're a linear pair. It's a quick, easy check for you. So now, all we want to know is, what is this guy left? Right here. Well, because this is an isosceles triangle, these base angles have to be congruent. So again, we're just going to run this same kind of idea. This question mark plus this question mark. These two added together. This question mark plus this guy. Plus my vertex, which I just found, 115 equals 180. Subtract 180 from both sides. You end up with both question marks. Sorry, let me back up. Add my two question marks. It gives me two question marks, right? It's like adding x. X plus x is 2x. Okay? So again, going back, subtracting 115 from both sides, I get my question marks equaling 65 degrees. Divide by 2, divide by 2. And these guys are 65 over 2 degrees, or you can call it 32.5 degrees, or I know you probably went to your calculator and you got 32.5 degrees. Yeah, it's all the same. Okay? So again, notice we just keep using that 180 degrees over and over again. And whenever we had isosceles triangles, the base angles were always the same. Base angles, and then there's my vertex, equals 180 degrees. Okay, base angles, there's my vertex, equals 180 degrees. This guy came from a linear pair. All right, this one right in here, where you got this triangle right here. Focus in on it real quick. So you can see that this guy right here, that's equilateral, which means that it is equiangular. So all these angles in here have to be congruent, which right away we know they have to be 60 because that happens in an equilateral equiangular triangle. All these are 60. Now what's this little symbol right down here mean? That's right, 90. So this angle, 60 degrees, plus whatever this guy is, they have to add together to equal 90. Okay? Because that means we're perpendicular, which means we have a right angle, which means we are 90 degrees. So my missing angle there, after I subtract 60, is 30 degrees. This guy right here is 30 degrees. Up here, this is 30 degrees. Now we can figure out angle C, which is what we want. And I knew this angle up here was 30 degrees because, again, this was isosceles. So in an isosceles triangle, these guys have to be the same. Have to be the same. Okay? So 30 plus 30 plus my vertex has to equal 180 degrees. It's a triangle. That's 60 plus whatever that is equals 180 degrees. Subtract 60 from both sides, and my missing guy is 120 degrees. Okay? So, just using a little bit of knowing that these two angles had to add together to equal 90. It's that angle addition postulate right there. And then using a little bit of my isosceles triangle. Base angles are congruent. And then all these angles in here have to add up to 180. Here's my base angle. Here's my base angle. There's my vertex. Here's my 180. All right, so now you got two more problems left. They're pretty much the same. I'm just not naming the angles this time. All I want you to do is find me the variables. So go ahead, pause the video right now. Try these out. Okay. So, looking at this guy. Again, we've got an equilateral triangle here. When you're equilateral, you're equiangular. So all these angles are the same, which means that they're all 60. Because equiangular triangle is always all 60. Okay? Then just like what we kind of did on number 5 up here, again, look right here. These two angles form this 90-degree edge right here, right? Which means 90 degrees, right angles. So that means that that angle 60 plus x has to equal 90. So subtract 60 from both sides. X is equal to 30 degrees. Y is pretty easy. We now know that this is 30 degrees, right? What do all the angles inside a triangle have to do? They have to add to 180. So to get this guy, it's going to be 30 degrees plus y degrees plus, well, we've seen this symbol lots. That means that that is a right angle. So that means that is 90 degrees equal to 180. 30 and 90 give me 120 equal to 180. Subtract 120. Y equals 60 degrees. So there are your two answers. Again, using equilateral, equiangular triangles, and then from there, a little bit of 90, and then a little bit of triangle sum. Okay? And then the last one. All right. So, well, what kind of triangle is this guy right down here? That's right, it's isosceles. That means this is congruent, and this is congruent, because base angles are congruent. So this angle right here has to be 55 degrees, right? So now we can easily figure out x, because again, we're just going to use our triangle sum. 55 degrees plus 55 degrees plus whatever x is has to be 180. 55 and 55, that gives me 110 degrees plus whatever x is has to be 180. Subtract 110 from both sides. X is equal to 70. Okay? Degrees. So I'm going to plug that in. Now, to get this triangle up here, well, there's one thing you got to remember. There's a relationship between these two angles. Back in Unit 1, you should have learned that these two angles right here are congruent because they are vertical. Vertical angles are always congruent. So we now know that this is 70 degrees. Now, working with our top triangle, this is isosceles. Okay? So isosceles means that base angles have to be congruent. So, all we got to do then is take my vertex plus my two angles that are the same. So this is y degrees right here. This guy has got to be y degrees. So it's just y plus 70 equals 180. Y plus y gives me 2y plus 70 equals 180. Subtract 70 from both sides. Y is equal 2y is equal to 110. Divide by 2, y has to be 55 degrees. Again, all we had to do was use isosceles triangles and the fact that their base angles are congruent. Isosceles triangle, base angles congruent. Another isosceles triangle, base angles are congruent. And then we had to use vertical angles to help get us from one triangle to the next. There's always some sort of key that gets you from one triangle to the next. Like in this one was vertical angles. And this guy up here, it was because we had a right angle. And our number 4 example up here, we had a linear pair. We like to do things like that. We like to keep congruent angles or use 90 or use 180 to help give us relationships between one triangle and the next.